Okay, so welcome to this video. So this is requested by Francis Chanda. So basically, cryptography exam for 2023, it was a combination for test 1 and test 2. Then on this channel so far I've done test 1 and test 2. So there's just one question which was added in the exam, so that's what we're covering. So let's do that. Okay, so first of all, we are going straight to question 4b. So keep in mind, they're saying using the RSA encryption algorithm, let P be equal to 3, Q 5, then N 15 and M 8. Let E be equal to 11. Compute D. So basically, we'll first do the things the way we do them, then I'll be showing you how it's done using the RSA conversion online. So let me open up my notepad first. Okay, so for us to compute D, we know that the formula is ED minus 1 over M. So we have that formula, but first we also need to list prime numbers which are less than N. So prime numbers which are less than N. So in this case, we know our N because our N is given as 15. So we will list prime numbers which are less than 15 by starting at 2, which is 2, 3, 5, 7, 11, and 13. So those are prime numbers less than N. Now, we need to understand one thing, that our E, based on the question, is 11. So we'll say 11 where there is supposed to be E. Then times D. In this case, we don't know D, so it will be blank like that. Then minus 1, we divide by M. So in this case, M we are given as 8, like that. Okay. So now for us to compute D, we need to understand that this blank space which represents D, we need to be testing out these prime numbers. If we get a whole number, it means that's our D from this list of prime numbers. So let me open up my calculator, we do that. Okay, so let's say we have 11, which is this. Then if we compute with 2 in place of D, it will be 11 times 2, which is 22, like that. 11 times 2, which is 22. Then we have this minus 1, so we say minus 1, which is 21. Then we need to divide it by 8. Divide by 8. So this is not a whole number, therefore our D is not 2. We go for 3 now. So again we start, we have this 11, so it's 11 times, then here we compute with 3, so it will be 3, giving us 33. Then we have this minus 1, we get 32. Then finally we have divided by 8. So once we divide by 8, we get a whole number which is 4. So you can see that this 11 times 3 from that list of prime numbers minus 1 divided by 8, we were getting 33 minus 1 divided by 8. Then we got 32 divided by 8, which is 4. Now we can tell from that therefore our D is equal to 3. Why? Because we have used this 3 from the prime numbers for us to get the number which is 4 as a whole number, but this 3 is the one which helped us to get this 4. So we are replacing it in place of D, no wonder it's our D. Okay, now let's go to the site. We do the same thing. So I'll just minimize this. Remember, this question is saying that we should use RSA. As you can see, this is RSA encryption algorithm. So let P be equal to 3. So if our P is equal to 3, we say 3. Then they are saying Q 5. So where there's Q, you put 5 like that. So based on the way we know how to calculate these things, so this is not part of the equation but just explaining. We know that our N is equal to P times Q, like that. Then based on the question, our P is 3, then times our Q, as you can see, is 5, like that. So if we say 3 by 5, we are getting 15. No wonder if you can see our N is equals to 15 and we were given. So same with this conversion site. If we pick 3 as P and 5 Q, they're saying calculate N is equals to P times Q. Same things, right? So you just say calculate N, then you click on it, it will give you the answer is 15. Okay, now let's see something else. Okay, so now this thing you are seeing as calculate phi, so this is phi, the one which looks like 4. Calculate phi is the same as calculating N. So, or M, calculating M, not N. So you know that for us to calculate M, we need to say P minus 1, then times Q minus 1. That's the formula. Then our P, based on this question, we know that it's 3, then minus 1, times our Q, we know that it's 5, minus 1, then we close. Now we can get, so 3 minus 1, as you can see, it will be 2, then times 5 minus 1, which is 4. So 4 times 2 is what we have, 8. So no wonder we were given our M, as you can see, as 8. So coming back to the site, if we say phi is for M, if we click calculate phi, we need to get 8. So that means our M is 8. So as you can see, we were given, I'm just showing you how they came up with these same digits. Now we go to a part whereby they say choose n number which is E. You see, so I won't read this but I'll explain. So basically your choices can go up to starting at 3, then up to 65,537. But based on the list we had, which is this, we were listing less than 15. So we can pick any of these prime numbers, and based on their question, they picked 11. So if they picked 11, as you can see, 11 is part of our list. So even here, we just need to pick 11. You don't calculate for E, you just choose. Under the same choose. So we say 11. Then after that, now we need to compute D. So we have already computed for D, but if you say compute D, it means we need to get 3. As you can see, it's 3. Simple as that. Very fast using a site, but you are not allowed to use this. I'm showing you this because it will be important for you to check that whatever you are doing is correct. Okay, now since we have found this thing which is compute D, now we go where it says find the encoded text for cyber. Okay, now at this point we know that this is the formula. I already explained last time, but I'll do it again. Then we need to input a certain plain text in this box. Then once we encrypt, it will be encrypted. If it's we put something which is encrypted in this cipher, we decrypt, it will be encrypted. So now let's do that manually, then we'll be using this site to confirm. Okay, so I'll go back here, then we are at question 2, like this. Okay, now we need to list our alphabet for us to know what number corresponds with this letter. Okay, so let's do that like that. Alright, now we have this plain text which is cyber. It's called the plain text because we are able to understand it. It's in clear format. So I will need to make sure that each letter on the cyber corresponds with a certain number. So C is 3, as you can see. Then under cyber we have Y is 24, O is 25, as you can see. So we say 25. Then we have B from cyber. Then B is equals to 2 on the alphabet. Then we have E, which is equals to 5 on the alphabet. Then last we have R, which is equals to 18 on the alphabet. Now, with this thing, we can start encrypting. So the formula for encrypting, as we all know, is that we need to have the key which we call the encryption key. So RSA encryption key is denoted by N, E because we're encrypting. So if we say N, E, in our case whereby N is 15 from the question, so 15, our E was given as 11. So we are using that to encrypt now. So the formula, since we're encrypting something, we need to come up with a ciphertext at the end. So for us to come up with a ciphertext, we say we need to have the plain text, which is denoted by M for message, then power encryption algorithm used, then mod N, like that. So since we know the formula, we can start encrypting letters. So for this one, we will start by encrypting the letter C from the word cyber. So C is our plain text to represent M, so it's at number 3. So we say 3, then power. Our E, as you can see, is 11, so 11, then mod N, so our N is 15. Now, opening up your calculator, because I'm using a PC, most of the things will be easier to do, but using a normal calculator, sometimes you can get exponentials at certain letters. But for now, let's just follow the normal procedure. So we have 3 power 11. So 3 power 11, we get that. So you copy, then you paste it there. Then you say mod 15. So as I said, mod is just like the same thing, then divide by that denominator, which is 15. Now, dividing this by 15, we get this. So I'll get this, copy, then you paste. Now at this point you need to get rid of that dot or point by doing this. Then you multiply it by the denominator, which is 15. So let's do that. So we have 11,809, then times 15, like that. So now we come to this number, so we copy, then we paste. Now at this point you need to get the first answer after powering it, then you subtract it from this last final answer you had for you to come up with the remainder, because mod deals with the remainder. So as you can see, this part is the same up to here with this up to here. So it's more like 47 minus 35. So we say 47 minus 35, like that, which is 12. So 12 on the alphabet is L, as you can see, where is 2 of A, L. So we have encrypted our C. So let's do the same using this site. Okay, so they have already computed the formulas for us. So if our M, which is plain text in our case, was C, C was at 3. So let me do this for you guys to confirm. I'll be doing this for now. Okay, so as you can see, C is 3. So because this site allows numbers, not letters, to represent C, we need to put 3. You see? Then you say encrypt. So encrypting it, we get 12, which is this 12 you are seeing. And on the alphabet, it's L. So we have confirmed that this is correct. We go to the next letter. So if you want, you can just be encrypting with this, but in the exam, you need to solve like this. This is for proof. And this site is just there to help you to encrypt something or choose some keys whenever you want to make a certain thing using this algorithm. Okay, so from the word cyber, we have this other letter which is Y. So we say Y. Then we have this formula used for encrypting like that. Okay, now our M or our plain text is 25 because it's Y. So we say 25, then power E, it's 11, then mod 15. Mod 15. So let's do that again. So we have 25 power 11. So this one will give you an exponential if you're using a normal calculator. So you need to know how to deal with exponentials. So 25 power 11, like that. So for me, because I'm using this type of calculator which is scientific, I won't get an exponential, but you guys are getting exponentials. So we'll get this whole number, a big one. Okay, and then we'll paste it here like that. We say mod 15, but remember this mod again can be represented as such by saying slash the denominator, or divide by the denominator. So we need to divide this number by 15. Then here we'll just get up to 2 decimal places. And then now we need to do that, paste. Okay, so we'll get rid of the dot whatsoever, decimal places like this. Then we say times 15, which was the denominator. Now I need to repeat this number, which is 15, 8, 9, 4, 5, 7, 1, 9, like that. Okay, 4, 0, 1, 0, 4, 1 times 15. So we get this now. So I'll copy this, we'll paste it here, and then from that, so let me put this here. So okay, now we can get this first answer we had after the power like usual. Then we'll paste it there, then minus this new final answer we have that. What's happening? So let me do Ctrl Z. So I'll show the minus from here, because so minus that. So as you can see, these all things are the same up to here, then even these are the same up to here, like that. So it's more like 25 minus 15, which is 10, so here I'll say the answer is equals to 10. Then on the alphabet, as you can see, 10 is J. So this can be encrypted to be J. Okay, now back to our conversion thing for us to confirm. So since our Y, the plain text was 25, so I'll just say 25. Then we encrypt if it's correct to be correct. So as you can see, it's 10, which is J. So if you are getting exponentials, you need to make sure that you're using a scientific calculator for you to avoid getting such digits. Or if your calculator has mode, you can simply do this. If it has the mode like this, you can compute everything like this, which is 25, which is this. Then you say power 11, like that. Then you get that. Then after doing that, you can say mod, which is this mod, then 15. So you say 15, like that. So you get 10 still. So it's correct. Okay, so now that you understand how to do this, so now that you understand how to use this and that, I'll just say, because I don't want to waste time, I'll say plain text, then cipher text. So as you can see, our plain text was cyber. So far our cipher text, we have L, then J. So to continue, now we need to convert B, so I'll just use this. So B is number 2, so here I'll just put 2, then encrypt. We are getting 8. On the alphabet, 8 is H, so here we put H, like that. So we have E, which is number 5, so here I'll put 5, then I encrypt this. Encrypt, we are getting 5 again. So 5 again, we get E, so this is the same as E, which is 5. So here I'll just say E. Then R, which is number 18, we say 18. Then we encrypt, we get 12, which was L, like that, L, or 12L. So lastly, we put L. So to confirm that this is true, we need to reverse it by decrypting. So decrypting this, we need to put these final answers we are getting. So for us to decrypt 12, which was L, to get back to C, we just say decrypt. So as you can see, this is 3. So 3 was C, confirmed. Then here to decrypt, to get back to our Y, if you are decrypting J, which is 10, you just put 10 under the cipher, then you say decrypt, you get 10. Wait. So we need to get back to 25, not 10. Cipher is 10. Okay, so I understand why it's doing this, because its reverse, this number was big. We need to be wrapping it around up to we get to 25. So maybe for us to count, we were at it's saying 10. It's saying 10, which is this. So if you count again, 1 2, let me do this, 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6. Anyway, but I'm sure you understand what I was doing. So that's the thing, and this is the answer. So this is Soko James representing KMU cybersecurity tutorials. See you in the next video. Keep on requesting for the questions you think they are difficult. Thank you.